Welcome, everyone, to the Innovation Flow podcast, where we talk about all things PARC, pilots, research, innovation in wastewater technology. And we're going to do that today with our guest, Brianna Miller. Thanks for being here, Brianna.
Happy to be here. Thanks for having me.
You bet. So Bri is an engineer, too, at South Platte Renew, and she's involved in a lot of the PARC projects. And what we want to talk to her today about is an innovative approach to, we'll get to it later. We'll get to it in a sec. It's about optimization. It's about wastewater treatment. It's all things cool in the wastewater world. But before we get into that, why don't you tell the listeners a little bit about yourself and your background and what you do all day?
Sure. So I'm Brianna Miller. I'm an engineer too here at South Platte Renew, as Blair said. I graduated from the Colorado School of Mines with a degree in chemical engineering. Right out of school, I wanted to move to the mountains, so I was a water and wastewater operator for the town of Telluride. After 2 years there, I wanted to use my engineering degree, so I moved to Sacramento, California, where I worked for a startup company and helped them design their technology to turn wood into plastic.
Oh.
Pretty cool.
Yeah.
But I really missed home, and the water industry, so I wanted to move back here, and I was lucky enough to land this gig, and it's so great because this is my dream job.
That's good. That's when you can finally find your dream job. It's rare and it's great. So we're glad to have you.
Thanks. Yeah, happy to be a part of the team.
Cool. What do you do? Do you still ski? You don't live in Telluride anymore, but do you still drive up and ski, or what do you do for hobbies?
Oh yeah, I ski all the time.
Yeah?
Yeah, I don't live in Telluride, but tonight I'm driving up and going skiing.
Oh, really?
Yeah.
Wow.
Yeah, I ski all the time. I like to hike, play with my dog. She can outrun me any day.
Oh, yeah? What kind you got?
I got a red heeler.
Oh, nice.
Do you have a dog?
Mine passed away. I used to have a chocolate lab, but
Nice.
she got, now we're bringing people down.
Oh,
I'm going to get another one.
okay.
I got to wait a little while. I got to let the sadness wear off. All right, let's move into happier things.
Okay.
Bri, if your life had a theme song, your job, your work life, or your personal life, what would your theme song be for your life?
That's a really good question. I think my theme song would be Dancing Queen by ABBA.
Oh, yeah?
Yeah, ABBA is fantastic.
I love ABBA.
Yeah, amazing. But two, it's just how I like to go through life, dancing all the time, looking at things, jiving with what comes my way, being happy, trying to see the happiness in all of life and dance your way through all your problems.
Nice.
Yeah.
I like your style.
Yeah, it's pretty fun.
It is inspirational. All right. Well, let's get to the science here, the science and engineering topic. Why don't you tell me a little bit about the optimization project you were involved in and what it was all about?
Yeah, sure. So this project was about optimizing our DAFs, and more in depth on that, we wanted to try and run our DAFs without polymer.
All right. So first off, what is a DAFT?
Okay.
D-A-F-T, right?
D-A-F-T, yes.
Okay, what is that?
That stands for Dissolved Air Flotation Tank.
Okay.
And what it does is it takes our solid stream here at South Platte Renew and it concentrates the solids. So we do that by using really fine bubbles, and it uses the bubbles to float the solids to the top and puts all the solids in one place at the top, where we can then skim it off the top and then send it to our digesters, and then it later goes on to our dewatering building and then gets sent to our farm.
Okay. So you have the solids, but they're not solid. Like it would probably what percentage coming out of, they settle in a big tank.
Yeah.
They come out of there at what, 2.5% or something?
No, 6%. 6% solids.
Out of the DAFT?
Yep.
But I'm saying when they come into the DAFT, what is it?
Oh, yeah, I don't know, maybe 2%.
So you're taking it from 2%, thickening it up even more, and what's the benefit of thickening that sludge?
So we can remove all the water, because it takes a lot of energy to remove water later down the process.
Yeah.
And we can then take that removed water and recycle it through the plant and then discharge it to the river.
Yeah.
So that's pretty cool.
Yeah, you don't have to have as big a tank either, I guess. You got
Yeah.
less volume.
Yeah, absolutely.
All right, so then this polymer. So somewhere in there you mix polymer. Tell us what polymer is and why you mix that in there. And yeah, so let's start right there.
Okay. Polymer is a coagulant. So it's a chemical that we use that helps us lump our solids together. So when you put it in, it creates bigger flocks of solids, and then that allows the bubbles to help float the solids easier.
Okay. So is it a liquid or a powder or
Yes.
what is it?
Yes,
All
both of
those?
those
Okay.
things. It can be a liquid or powder. We have to make it into a liquid. We have a liquid form, but sometimes it's powder that you have to make into a liquid.
Okay.
But yeah, we're dosing it in
You
there.
put the liquid in, it mixes with the water. Then it's like opening a bottle of 7-Up or something. The bubbles come up and grab the flock, you call it, the particles, and takes it, concentrates it, takes it away.
Correct. You
Okay.
got it.
All right. So you're trying to do it without polymer.
That's right.
Why are you trying to get rid of that polymer?
Well, let me tell you
What
the
did the
little
polymer
backstory.
do to you?
Yeah, let me tell you the backstory.
All right, we need the backstory.
So we have only one polymer site at SPR.
Okay.
And that's located at our dewatering building. And our dewatering building is about like a quarter mile-ish from our DAFT building. So we need to pump all that way to our DAFs. Well, this makes it hard for us to do maintenance, for us to see what's wrong, things like that. So we wanted to put our own polymer system in the DAFs. But when we priced that out, it was a little more expensive than we thought it was going to be. So the reason behind this pilot is to try and see if we can get away with running them without polymer and therefore not having to put a new polymer system in the DAFs.
Yeah, or buy polymer. There's got to be savings.
Exactly.
Yeah.
We'd save a ton a year in chemical costs.
All right, I like it. So take us through that. Take us through that study a little bit. How'd you do it, and what did it show you?
Yeah, absolutely. So we're running this study on our full-scale system. A lot of pilots we run on a separate site, but this one we're running full-scale in our DAFs. So we didn't want to disrupt the plant too much by doing this. So we typically only run one DAFT at a time. We have 3 total on the site. And to do this pilot, we decided to put 2 DAFs on.
Okay.
Yeah. And what this did was it allowed us to have a control group. So we ran 1 DAFT with polymer and 1 DAFT without polymer.
Nice.
So control group would be with polymer, and without polymer was our experimental group.
This is taking me back to science fair with the control group, the experiment, the hypothesis. Yes, I'm right with you.
You're ready. You're
Yes.
there. So we did that, and this also gave us a way to not implement the plant too much. So we were only dosing half of the flow without polymer.
Okay.
So that way, if things went totally crazy, then it wouldn't upset anything too much.
Yeah.
Well, that was a hope, anyway.
Yeah.
So the second question was, what did we see?
Well, before we get to there, I guess what were you looking at? How were you measuring? What things? What things were you looking at and measuring?
Yeah, absolutely. So the main things that we were looking at was the subnatant total suspended solids.
Subnatant. Would that be the clear liquid underneath the foamy goop?
That's right,
Yeah.
you got it.
All right, and what did you say after that?
I didn't say. I said after. I guess after we looked at the float total solids, so the
Okay.
percent solids.
Okay.
So the slimy goop.
All right, so
How
you
many
measured
solids are in there?
the thickness of that and how much solids didn't come out and was still in that liquid phase.
Correct.
Okay,
Yep.
And
And then we compared them between our control and our experimental.
awesome. What did you find?
Well, at first we got really poor results, like really bad. But we stuck with it. So we kept going and we changed some things, and we found that we could get the subnatant total suspended solids down to about 300 milligrams a liter without dosing any polymer.
Okay.
Now, when we dose polymer, we get it down to about 150 milligrams per liter. So it's still not as efficient as using polymer,
Yeah.
or not as effective, but it's still really good.
Yeah.
And then what we saw in our float total solids is that we could get them to be almost identical. So we were seeing about 5.5% solids when dosing polymer, and without polymer, we were seeing about 5% total solids.
Okay.
Yeah,
That is promising.
I think so too.
Yeah.
Yeah.
So what are what happened next? What are the next steps? What are you going to do with this information, or are you going to do anything? And where is this going from here?
Yeah, absolutely. So we stopped the pilot and we want to start it back up again. So our next steps are to do a phase 2,
Okay.
where we now have more information that this can work, but I think we're going to approach it with more structure.
Okay.
Yeah, so we're going to do like a week by week, what are we changing? Are we changing the skimmer speed this week? Are we changing the pressure of the air this week, up or down? And then really nailing down what's happening with each of those changes.
Yeah.
Yeah.
So isolating some of these variables that maybe that you learned needed or would be better if you isolated them on the second run and drill down exactly onto why you're getting what you're getting or not getting what you're getting.
Yeah, exactly.
All right.
Yeah, pretty cool.
Yeah, this is pure science. This is pure scientific method stuff. I like it.
That's right.
So what did you learn from all this? Either, I know you learned about the percentage of solids and the different concentrations, but on a larger scale, what did you learn about yourself? What did you learn about the plant? What did you learn about, in addition to the scientific data?
Yeah, absolutely. Well, first, about the plant. This is the first plant I've worked at that had DAFs, so I just thought everyone had circular DAFs. Turns out, we're like one of the only people who have circular DAFs right here at South Platte Renew.
Okay, what
Crazy.
shape are most of them in?
Rectangles.
Okay.
I know. So that was pretty cool. And second, I learned a lot about DAFs, how they work, how to adjust the flow rate of the air, how to move the skimmer height. Just like gave me a really good appreciation for operators and the jobs that they do.
Yeah. So when the bubbles come out from the bottom, is it just they're always coming out, or does it shoot them out there in is it continuous bubbles or just shots of bubbles?
Continuous bubbles.
Continuous bubbles? Okay.
Yeah.
All right.
Yeah. Pretty nice.
All right. Any other takeaways? Any other lessons learned?
Yeah, what I learned about myself.
Here we go. This is
It's kind of deep.
Yeah.
But it's that you can't do everything by yourself.
Yeah.
It really takes a team, it takes an army to do all of this. And it was really cool to go through this pilot because we get a lot of buy-in from all of our staff here at South Platte. And so it was great to see everyone's ideas come together and mesh them. I thought coming in that I would have to run it all by myself and come up with all the ideas, and I was ready to do so, but I didn't know anything.
Yeah.
And I learned that. And a lot of people know a lot more than me, and really leaning on them made the pilot much more of a success.
Nice.
Yeah.
Well, that's a good lesson for the pilot and for life. You
Yeah,
know?
absolutely.
You utilize those around you, and a lot of times you'll find out they're eager to help and knowledgeable.
Yeah.
Good. I like that
cool.
lesson. All right. Do you have any other any takeaways, any questions I didn't ask you that you want to answer for the listeners?
I just want to touch on that before we started the pilot, we did come up with some KPIs.
Okay, yeah, KPIs.
Yeah.
Tell me about those.
Yeah, so we set some parameters that we didn't want to exceed, so we knew if it was completely failing or not,
Yeah.
or disrupting the plant or anything like that. And then, so that was, we were looking at our TSS from the subnatant. We had KPIs on that, which we did exceed one time, but that was okay. And we just talked through it as a group and moved forward and then fixed it. And then we were also looking at our metals concentrations in our effluent because we didn't want to mess anything up downstream.
Yeah.
Yeah, so the theory behind that was if we're putting more solids in the liquid stream and then it's circulating, there could potentially be more metals that could be getting into our effluent.
Okay.
So we were really monitoring that. And I think that helped us keep on track a
Yeah.
lot. Mm-hmm.
Good.
Guidelines.
How did you, or did you, and maybe this comes up in your second phase, but at a plant, 20 MGD plant, there's many processes, DAF's one of them, but there's things happening everywhere.
Yeah.
And how do you isolate work, or was there work being done other places in the plant? And if so, how do you isolate that, or can you isolate that, or does that have any effect on the results of the DAFT experiment?
Yeah, absolutely. There's no way for us to isolate it. We just didn't want to be implementing the downstream processes too much, so that's why we did the 2 DAFs. But there's absolutely things that are coming in play here for the DAF pilot that we maybe in phase 2 we're going to do a better job of keeping track of and looking out for.
Yeah.
But everything is a process. So
Yeah.
so something feeds the DAFs, the solid contact tanks or or the secondary clarifiers, feed the DAFs, and that's the inlet concentration for this experiment.
Yeah.
So we need to do a better job, think second time around, keeping track of what's coming in
Yeah.
too, and not just what's going out, and looking at what's going out so we don't disrupt
Yeah.
everything else.
So it sounds, so you try to isolate the variables you can, but at some point it's a working plant and things are changing all the time, right? And so
Yeah.
at least knowing that maybe informs, some of the results or outcomes that you get.
Yeah,
Cool.
absolutely.
All right. Well, thanks for coming by and telling us about this project. I'm glad. Who thought of this? How did this come about? Where did this idea come from? Who said we ought to look and see if we can do the DAFT without polymer?
I don't know who it was, but they're a genius. Well, we'll see.
All right.
Yeah.
Well, thanks for sharing it with us, and thanks for heading the whole thing up and explaining the scientific methodology behind it.
Yeah, absolutely. It was a pleasure.
Yeah. Are you ready for the end of the show activity now?
Okay, I'm ready.
Okay. Earlier, I think yesterday, I gave you a whole afternoon or evening to do it.
Yep.
I asked you to write a dating profile for a DAFT if they were on. I'm too old. I don't know the dating sites, but farmers.com.
Yeah,
or,
perfect.
Yeah, okay. So if you're writing a dating profile for the DAFT, and I wrote one too, we can compare.
Okay.
So give us your dating profile for DAFT.
All right. So my DAF's name is Daphne A. Flote,
Wow. Okay, I like it.
but her friends call her Daph.
Okay.
She is around 30 years old, but her people have been around since the 1900s.
Okay.
Yeah, when they were first invented.
That's
Yep,
a strong family lineage there.
that's right.
Yeah, okay.
Yeah. They're not going anywhere.
Yeah.
They're sticking around. Yeah. So a little bit about her. She's all about rising to the occasion, literally. She's using those fine bubbles to lift the solids away, making life clearer and smoother for everyone around her.
Nice.
She's into efficiency and reliability. She's low maintenance, and she's just great to get along with.
Wow.
Yeah,
All right.
I know. And let's see, some of her likes is she likes good chemistry.
Oh.
Clear communication that's well mixed and balanced.
All right.
Yep. She likes a steady flow, no turbulence, just smooth operations.
God, that's me too.
Oh, yeah. And she really likes eco-conscious partners because she's part of such a sustainable, clean water future.
All right.
Yeah.
Well, bravo.
Uh-huh.
That is a. I think she's got a good shot out there on the dating
On
site
farmers.com.
on farmers.com. All right. I don't know if I could top that. I don't even want to read mine now.
No,
That
you
was
got
pretty
it.
good.
Yeah.
Okay. I just called mine Daft.
Perfect.
I have a bubbly personality.
Uh-huh.
Always lifting up those around me. Great under pressure. Love micro bubble baths and polymer spa days.
Oh, yeah.
Yeah, I'm looking for someone that appreciates the clarity I can bring, but is not afraid to get a little scummy.
Perfect.
Yeah, swipe right if you're ready to float through life with me.
Perfect.
Huh?
Wow, I like it.
We got to post these, see if we get some hits.
Yeah, we'll see. Yeah,
All right.
I'm sure they can find love.
Cool. Well, thanks for being here, Bree. It's been a pleasure having you on, and thanks for sharing the information about the DAP pilot project and the scientific method and how to look at something, make improvements, and strive to carry on.
Yeah, absolutely. Thanks for having me. It's been a pleasure.
You bet. And to our listeners, if you're enjoying the flow, give us a 5-star review or a thumbs up or a like or subscribe. We appreciate you listening to the Innovation Flow podcast, and we'll see you next time on the Innovation Flow.